Number 19, find the exact solution by using the quadratic formula. So what we need to do is simply identify your a value, which is 1, your b value, which is -3, and your c value, which is 1, and then use the quadratic formula. And there's the quadratic formula. You have to memorize it. Now the trick to using the quadratic formula, the safe way to use it, is to replace all your variables with parentheses. Let me do this up here. And then after you do that, just simply plug in your b value, which is -3. It's going to go in right there and right there. So let me do a -3 right there, -3 right here. Your a value is 1, so you plug in a 1 right there. Your c value is also 1, so plug in a 1 right there, and your a value is a 1. So whenever you have your quadratic formula, I'm going to work this off up here on the side. Always start with your discriminant value so inside the square root. So you have -3 squared, that's 9. So you really have a 9 minus 4 times 1 times 1, that's 9 minus 4. That's inside the square root. There's a plus minus right in front of it. The minus 3 changes to a +3. It is divided by 2. So again, let's continue working with the 9, take away 4 inside of the radical. So the final answer is 3 plus or minus square root of 5 over 2. Okay, so there is no need to split it. That's your final answer. And if we check down here, correct answer is D. Boom. Let's try another. That's the next one's not multiple choice. You actually have to work it out. So once again, let's replace the formula with the variables with parentheses. Happens to be 5. No, I mean the b value happens to be 5. So put a 5 right there and a 5 in there. The a value happens to be -1, and the c value happens to be -7. And down here the a value is -1. So we're going to work on the inside of the square root. That's our discriminant value, and we will have a 25 minus, because when you think about it, a negative times a negative times a negative is going to be a negative. So you put minus, and it's really just 4 times 1 times 7. That is 28. 28. So you have your square root, the plus minus, a -5 in the front, and also a -2 on the bottom. So when we continue working here, the 25 take away 28, that's going to be -3. So you're going to end up with, let me move this to the side, you're going to end up with -5 plus or minus the square root of -3 over -2. Now the square root of -3, the 3 you can't simplify, but the negative, you're supposed to pull out the I from there. So let me move this to the side some more. So moving it over, you are going to end up with a -5 plus or minus I square root of 3 over -2. Now because there's an I, you have to split it. So it's going to be a -5 over a -2 plus or minus. We might as well write the square root of 3 over 2, but the I that was in the front, let's write it out here at the end. And the only other thing you could do is change the negative divided by a negative into a positive. So there's your final answer, 5/2 plus or minus the square root of 3 over 2i. Jumping to number 20, A, B, or C, you need to find the value of the discriminant, and the discriminant is always the value inside the square root of the quadratic formula. So it's simply b squared minus 4 times a times c. Now there's a couple of things that we've discussed already about b squared minus 4ac. If the discriminant happens to be negative, so let's say you're working on the quadratic formula and you see that that inside value is negative, well, you know that you're going to end up with imaginary numbers, so you're not going to get real answers. Okay, so if it's a positive number in here, then you are going to get 2 real answers, and if it's 0, then the square root of 0 will be 0, which means you only get 1 real answer. Let's go back over here and actually do one of these. So 20a, we're going to just replace the letters b squared minus 4 times a times c. Of course, you guys get to use calculators. So b squared, inside there, it's going to be a negative 27 squared. And then 4 times a, that's 4 times negative 3, times 19 at the very end as your C value. So from here, it's a great idea to grab a calculator and work this out and get an answer. So 27 times 27, 27 squared, that's 729. Let me just write that down right here, 729. And we do have a negative 4 times a negative 3, that's positive 12. And then 12 times 19 is 228. So we're going to add 228. I'm doing this on the calculator, by the way. So 228 plus the 729, you're going to get 957. So the answer to number 20A, the answer is, the discriminant is 957. So this is your discriminant, and what does that discriminant tell you? It tells you, because it's positive, it tells you that you're going to have two x-intercepts. That you're going to have two solutions, right? Real solutions, two real roots. They are not complex numbers. Complex numbers are imaginary, and imaginary numbers come from discriminants that are negative, and this discriminant's positive. So I hope that helps. Let's move on to 20B, 20. Let's just jump to 20C here. Okay, so let's do negative, or actually the discriminant is b squared minus 4 times a times c. So that's 5 squared minus 4 times 13 times 3. So 5 squared is 25, and 4 times 13 is 52. And 52 times 3 is 156. So this right here ends up being 156. And when you take away 25, take away 156, you end up with negative 131. So this is my discriminant value. Now, because my discriminant value is negative, what could I say about my answers? It has no real answers, right? Or no real solutions. Or you could say that it has two complex answers, or two complex roots, or two imaginary answers. But the bottom line is there are no real answers. You could also say that this has no x-intercepts. Okay, I know that the parabola a value is positive, so it's opening up, but this parabola it opens up must be above the x-axis on your xy plane. Okay, because the parabola will not cross. It won't cross the x-axis. It's above the x-axis. So it doesn't have any real x-intercepts. Jumping to number 21. Writing it in vertex form. Well, you could complete the square to write your function in vertex form, or you could simply find your vertex, because vertex form is y equals a parentheses x minus h squared plus k. Now, all you really need to write something in vertex form is your a value, your h value, and your k value. So the a value is always the number that's out in front. If you have a quadratic trinomial, ax squared plus bx plus c, then your a value is simply the number that's out there in front of the x squared. Your h and k will always be your vertex, right? So your vertex is your h and k value. So do we have, if we look at 21a right here, do we have an a value? Yes, we do. It's negative 3. So the a value, let me just write this, a equals negative 3. Okay, now do we have a vertex? Well, it doesn't give us the vertex directly, but you could always find the vertex. Hopefully you guys remember how to do that. You find the vertex by doing the formula x equals negative b over 2a. And of course, when you use this formula, use parentheses when you plug in your values. And the b value right here is 30, and the a value is negative 3. So you really end up with negative 30 over negative 6, which means that your vertex x value is positive 5. Okay, And again, your vertex x value is really your h value. Now your vertex y value will be your k value. So if we do have the vertex x value, how do we find the y value? We simply take that 5 and plug it back into x on both of those. So what I want to do is I want to rewrite this equation probably up here. I want to rewrite this equation, but without the x's. I want to put parentheses instead. And of course I want to plug in that value of 5. And you guys could use calculators. So you really have negative 3 times 25, because 5 squared is 25, plus 150. So what we really have is negative 3 times 25, that's negative 75, plus 150, that's actually going to be positive 75. So we have our vertex. We have our h value, which is 5, and our k value, which is 75. And we already found our a value just by looking at that first term over here on the a value of the standard form. So now that we have a, h, and k, we have this number, we have this number, and this number. All we got to do is plug it in, and that'll be our vertex form equation. So let me just move this to the side a little, and let me write my equation right here. It's going to be y equals a, which happens to be negative 3, parentheses, x minus h, which is a minus 5, close parentheses squared, plus k, which is plus 75. So there's my final vertex form equation. Let's move on to the next one. I want to jump to number 21. So again, if you want to write it in vertex form, you could complete the square if you wanted to, but I'm just going to say go with the vertex. Find the vertex. You already see your a value right here is 1, so let's find that vertex. X equals negative b, which is negative 8, over 2 times a, which is 2 times 1. So you have negative 8 divided by 2, which is negative 4. So we found the x value of the vertex. So here's your vertex coordinate. You just found the x value, which is negative 4. Let's find the y value now. All you got to do is take that negative 4 and plug it in right here into this x and into this x and work it out. So I want to rewrite this whole thing. I want to rewrite it in red right here. And I'm going to plug in the x value of negative 4. And I'm going to work this all out. So right here I have 16. And 8 times negative 4 is negative 32. And of course I have a plus 1 right here. So I really have negative 16 plus 1. That's negative 15 as my y value. So I'm going to go back to my vertex and put a negative 15 right there. Now I have my vertex that's really an h and a k value. So I already have my a value up here of positive 1. So if I have my a, my h, and my k, again a is 1, h is negative 4, and k is negative 15. So I'm going to plug it in. Let me move this to the side. Let me rewrite my vertex form equation here. And all I'm going to do is substitute these three values into my vertex form equation, and I'm good. Check it out. Y equals 1, parentheses, x minus, this negative 4 is going to go in right here, and notice that it's a minus negative that I am going to have to actually switch. Now the k value is negative 15, so I don't have to put a plus. I could erase the plus and put a minus 15 at the very end and change the minus minus to plus plus, and ladies and gentlemen, this is your vertex form equation. Piece of cake.